So just focus on little things that I mention as I go along, okay? So graphing data. To rent a car for less than 1 week from Ace Car Rentals, the cost is $65 per day for the first 3 days. Then it's $60 a day for each additional day. Okay, and we're gonna graph that here. But first, I'm gonna ask a whole bunch of questions and see if you can answer them, right? Identify the independent and the dependent variable. And the independent variable would be the number of days. Number of days, that's fine like that. And the dependent, it would be the total cost. And think about it. The number of days determines how much you're going to pay, right? So the cost depends on how many days you're renting it for, not the other way around, right? So that's that. To graph, now we're going to graph this data, right? Be sure to choose an appropriate scale, label the axes, give the graph a title, okay? And it goes without saying, actually plot those points. So I think we're good with just going up by 1. Okay, so I'm going to go number of days. Of rental, if you want to be very specific. So basically, this tells you what the units are, right? So the title also gives you the units, so no need to put down any units there. Total cost. There you have to make sure you put the $sign in. Okay. The title, car rental costs. So notice that I haven't graphed a single thing yet. I do that first, get it out of the way. And then I'm just gonna label every second one. I'm not gonna label every single one. I encourage you to do that too. You know what? Hold on, folks. I like to have things spread out. So there's enough room to make every second box worth 1. Yeah, there's enough room. So we'll do that. Like don't cram it if you don't have to, right? Like spread it out. So every second box is worth 1, and I did label every single one, right? 1, 2, 3, and so forth. And then my cost, I need to go, this is okay to start at 0 and go all the way to about 400. That's what I'm going to do. So I wonder if I start at 0, if I make every second box 50, so 50, 100, 150, 200, 250, 300, I'm gonna run out of runway there. So I might have to make every second box 75. So I'm going to make this 75, and so I'm going up by 75 now. And it's always best to go up a little bit if you can, if you have the room. You could have gone up by, whatever you like, whatever works for you, as long as it's consistent. And I'll make it consistent. Right? Under the appropriate scale, make sure it's consistent. That's what I care about. I don't care about, sometimes it makes it easier to pick a good scale. But other than that, I don't really care. So let's go, and after 1 day, it'll be 65. So it's somewhere in here. After 2 days, it's 130. So it's somewhere there. After 3 days, it's 195. Right there. After 4 days, it'll be 255, somewhere there. After 5 days, it's 315, somewhere there. After 6 days, it's 375, right there. Appears to be a straight line, right? If you look at it. Okay. Does it make sense to join the points on the graph? Explain. Okay. And the answer will be number of days. It's implied, right? You can't rent a car for half a day and bring it back and just get half of your money back. It doesn't work like that. You pay for the day, right? So it doesn't make sense. The cost, this is continuous, but this is not. This is discrete, okay? No, and we'll answer because you can only rent the car for whole number of days. Oh, sorry. No, because you can only rent the car for whole number of days. No fractions, decimals. Therefore, it's discrete data. So we do not connect. As soon as one of them is discrete, you do not connect. You can't. So it's only whole day increments there. Is the relation a function? Explain. It is, right? Like there's no point where you do the vertical line test where you would cross more than one point, right? Yes. Each input domain element is associated with a single output range element. If you said, yeah, because each x value is only pointing to one y value, I would also honor that. What is the domain and range? Domain in this case, you got to go from lowest to highest. And I think I forgot to mention this. It has to be in alphabetical order if there had been words. So if it's words of any kind, even colors, right? Blue, green, yellow, right? You have to arrange them in alphabetical. That's like the norm in math, right? I don't think I mentioned that before, so now you know. So the domain here would be 1, 2, 3, 4, 5, 6. Oops. Squiggly brackets. You can only do set notation with discrete, okay? And then the range would be 65, 130. It's already arranged for us, so we just need to copy really. No interval notation for discrete data, okay? There's a little note here. We can only use set notation there because we can't do things in between. And here's a bit of a reminder of discrete versus continuous. Discrete points on the graph that are not joined can be numeric, right? It could be cost. number of people, number of cans, number of days, etc. Could be numeric things or categorical. Could be food groups, colors, cities. Like number of cities with a stadium, right? You can't come up with 2.5 cities have a stadium, right? It would have to be whole numbers there. Continuous, things you can measure that can be measured. That's my go-to definition, things that can be measured. So volume, weight, temperature, height, distance, etc. Okay. Okay, so now we're going to review a little bit of graphing using table of values, okay? So on the back side of this, this is how we're going to approach it first and foremost. To graph a linear relation from an equation, first create a table of values, then plot data on a table, in the table on a grid. Table of values, folks, I sometimes just use TOV, okay? If you hear me say TOV, it's a table of values, right? And so essentially, I want you to think of it this way. You get the equation. The equation allows you to make a table of values, and then the table of values will allow you to graph this thing. But you could also go from graph, and we'll do that later, to table of values to equation. Okay, this we'll do later. This is what we're going to do now, right? We're going to go from equation to a table of values, and then we're going to graph it, okay? And by the way, especially in math and pre-cal, like the popular ones are to use -1, 0, and 1. Don't go too crazy with your x values. Pick smart values that are close together because you just want to see a pattern. What you're really doing when you're making a table of values is you're finding 3 points that will lie on that line, and that's all you need to be able to graph your line, okay? So watch what they're doing here, and we'll do that again. So if we're asked to graph -4x plus 6, we're picking x is equal to -1, then we're picking x is equal to 0, and then we're picking x is equal to 1, and we just substitute that in. We're substituting these values into that equation that we're given here, and we get our y values for these corresponding x values. So let's say x is equal to -1, right? So it's -4 times -1 which is just 4, plus 6 is 10. So really you found a point -1, 10. Okay? That's what you just did here. Remember, it's a machine. You feed it something, it will give you an output, and that output is the y value. Over here, you found 0, 6. Okay? When x is equal to 0, y is equal to 6. So, right? So the -1 came from there, and the 10 comes from there. And so here again, y 2. Okay? And x is equal to 1, y is equal to 2. Okay? Write the values of x and y in a table. So we're basically translating these into a table like this. Okay? And remember, it's always, these are always points. These are always points that you're just splitting them up into a table of values. Then we plot these on a grid, right? So when x is equal to -1, y is equal to 10. When x is equal to 0, y is equal to 6. When x is equal to 1, y is equal to 2. And then you connect your, since the data is not discrete, you join the points. So no context, connect points. How do you know there's no context? Well, if it's just giving you an equation with no words around it, you don't know what x is or what y is, you assume that you can connect the points. Okay? You assume everything goes. Okay? So now I'm going to ask you to graph using these equations. I will do a couple with you, and we'll do them in the back, right? See back. Okay? So we're going to have to flip back and forth, unfortunately, but we're going to do each one individually. And these grids are provided to you on the back side to actually graph, okay? I think you should be able to use this blank page before it, right here, to create your table of values, and then you transfer it over to the graph, okay? So for A, we have y is equal to 4x, okay? And I will show you a slightly different way of creating a table of values because we have the room, okay? So you make your table of values, x and y, and so we'll go -1, 0, and 1 like this. And we'll actually do the work right in the y column. It's a little bit different, okay? So how do we get y? Y is equal to 4 times, in this case, x is equal to -1. You plug that in here. So 4 times -1 is actually fairly easy to do. That's -4. So you just found 1 point, -1, -4. When x is equal to 0, you go 4 times 0, and that's 0. I hope you know that. Anything times 0 is just 0. And then y is equal to 4 times x again, where x is equal to 1, that's just 4. This is your table of values. Slightly different than the previous page, right? So now that we have these points here, let's go ahead and graph it. And the grid is provided to you, right? So I'm going to go just, maybe I can just do this. Yeah, I can do that. So this is A. Y is equal to 4x. We'll put that up here so you know which one you're graphing. So when x is equal to -1, -1 is right there. Y is equal to -4, just plot it right there. When x is equal to 0, y is also equal to 0. So that's the origin. Make one a point right there. And then 1, 4. And x equal to 1, y is equal to 4. Right there. And then use your ruler and you just connect the dots. They should line up, by the way. A linear equation should line up. And so this is what I'm going to ask you to do. Make sure you extend past the points you've graphed. Don't just stick to, some students just go from here to here and they put an arrowhead right where the dot is. Just continue, because you found 3 points that lie on it to help you graph it, but really there's an infinite number of points on that line. Okay. And by the way, you should technically put the equation right next to the line. That's the norm for us. Okay. And technically there should be, the axes should be labeled. So we should put X here and Y there. Unfortunately, these grids do not have it, but I'm actually happy, because if you have to do this by hand, you're going to remember to put an X and a Y there. Okay. So again, scale is there. Labels are there. And you also labeled your equation. Okay. So I'm going to highlight this. Important, right? From now on, because we're going to graph. Always add equation. Okay. Mr. Dirksen, could I use -5? Could I use -5, 1, and 10 for my x values? Absolutely. Is that smart? Nope, it's not smart. Why? Because now you're running into a problem, because you don't even have x equals to 10 on this grid, right? So you want to keep it very close together. That's why I picked -1, 0, 1. But just keep in mind that I could ask you to make a table of values where I give you like random x values and you just figure out the y values. Okay. I can also give you fractions. So this is right now just warm up. So I would say this is your homework. Graph all, right? And you know where you're getting your equations from, right? It's that back side. And the table of values should all be here. All that work should be here, worked out. Do not just eyeball it, okay? Do not just do it in your head. You want to work it out to get full marks. And you probably make mistakes along the way if you don't. I think I have enough, right? I have eight grids, and I have 8 questions. Yeah, 8 equations you need to graph. So, and unfortunately, I don't have any fractions here. No fractional, but that's okay. We'll figure that out down the road. Let me just pause the recording there. It's not that, this one isn't that bad. Like, you just have to be able to read a graph, which you have been doing already. So it's a little bit of review. Let's just talk about this before we go. Consider the following linear. Linear, you should think of a line, right? Straight line. And non-linear, obviously, it's not a straight line. Okay. Create a table of values from the graphs, then answer the question below. Always start with the point that is farthest to the left. Okay. This will also be part of your homework. Whatever I don't do, you will do this for homework. So no textbook stuff, it's all just this stuff, and then tomorrow I'll go over it. But this is how this goes. So for example, when x is equal to -3, so you're going to use this graph to fill in the table of values. So -3 and then -2, when x is equal to -2, y is equal to -1. When x is equal to -1, y is equal to 0. So you basically just read all those points out into your table of values. This is a table of values, right? So you transfer that in there. So I want you to fill that in for tomorrow as well. It's not that hard. It's just, can you read the graph and write those values into that table, okay? And then we'll continue. This is basically a bit of a warm-up before we do our next thing. Also, we're gonna have our quiz on Monday, April 23rd. Yes, it's 23rd. And that's gonna include everything up till tomorrow, okay?